Hi, I'm Brendan, and I'm here to talk to you about how Kubernetes works. Fundamentally, at its base, Kubernetes is about taking a bunch of virtual machines, or physical machines for that matter, although these days in the cloud I mostly think about virtual machines, and transforming them into a unified API surface that a developer can interact with containers and orchestrate their application without really thinking about the machines that lie below. So this is the Kubernetes API surface area. We abbreviate Kubernetes as K8 sometimes. It's shorter and easier to write. The 8 stands for the 8 letters in between the K at the beginning and the S at the end. The Kubernetes API presents a bunch of different pieces. The core ones are a pod, which is a collection of containers that are co-located on a single machine, a service, which is a load balancer that can bring traffic down to a collection of pods, and then a deployment, which under the hood uses a replica set, which, as the name suggests, is used for replicating a container multiple times for availability or scale. So this API that is presented is a JSON-based API. So if you have a user here who's interacting with Kubernetes, they use the kubectl command line tool, generally, although and other tools have been written to interact with the API. That makes an HTTP call to with JSON to the Kubernetes API server. So let's take a look at how we put this together to actually build a real application. Well, let's suppose I have a simple web app. It's going to be a container image. So I have my image over here. I want to create pods to actually run that image and to run my application on the Kubernetes API. To do that, I'm going to create a deployment. And so I'm going to say, hey, I want to create a deployment. It's represented generally as a YAML file. I'm going to create that deploy.yaml. I'm going to say kubectl apply, and I'm going to give it that file. And that's going to send it through to the API server. And the end result is that it will create, let's say if I said 3 replicas in here, it's going to create 3 pods. In the Kubernetes API, which will result in the scheduler placing 1, 2, 3 containers on the virtual machines that actually act as the host machines for the service. But obviously, this is only the beginning, and there is this deployment object over here that is managing and ensuring that there are 3 of these replicas. This is really only the beginning. I have my application up and running, but I need to actually expose it to someone to be able to consume it. To do that, I create a service. And the service is a load balancer that knows how to take traffic either from the outside world or from another service inside the cluster, and then load balance that traffic down to those containers. Now, if I want, I can actually say that this service is attached to an external load balancer. If it's attached to an external load balancer, then Kubernetes is actually responsible for going and talking to the cloud and requesting that that load balancer come into existence so that I get some IP address. That IP address is mapped to the cloud load balancer that is then mapped to the service and all the traffic. So that way, if I have an end user accessing it, they can talk to that external IP address. Traffic will flow through the cloud load balancer to my service, be load balanced out to all my containers. In this way, if I go to the deployment and I actually change this from, say, 3 to 4, the declarative nature of Kubernetes, the self-healing nature of Kubernetes will say, you only have 3 replicas here. I need a 4th. Traffic flows from the load balancer out to this 4th replica. My end user doesn't even notice that I've scaled up the application. So that gives you a really good illustration of why Kubernetes is great for deploying reliable applications, scalable applications without affecting end users. And in fact, you can actually do a rolling deployment where you move from, version 1 of your container to version 2 of your container. In place without your end user noticing at all. We'll talk more about how that works in the next episode.